see the different types of quadrilaterals. First one, square. You all have drawn squares, you have observed squares. Here we find that the main property of a square is that all the sides are equal. If all sides are equal, that means all the sides here, which refers to AB, BC, CD and DA. So if one side is given as 2 centimeter, then we can say that all the other sides will also be 2 centimeter. So it can be given that AB is to find out BC or CD or DA. So it is a very direct, easy question that since one side is 2, all the other sides will be 2. So first property, all sides are equal. The second property of a square is that all the angles are going to be 90 degrees. All angles are 90 degrees means angle A and angle B, C and D will all be equal to 90 degrees. And the total, of course, for any quadrilateral will be 360, and here it is clearly observed that 90 into 4 is 360. So all angles are equal. Join A to C and join B to D. These are called the diagonals. The diagonals of a square are equal. So we can say the length of AC will be equal to BD. The length of the diagonals are equal. That's property number 3. And also another important property, when we join the diagonals, the intersection point, if I am marking it O, it will always intersect each other at 90 degrees. So we can say that diagonals of a square intersect each other at 90. So all the angles AOB, BOC, COD and DOA will all be equal to 90 degrees. And also the diagonals of the square will bisect each other. Bisecting each other means OA will be equal to OC and OB will be equal to OD. Now if you look at the second figure here, that is a rectangle, and you will find here that in a rectangle one side is bigger than the other. It is not like a square where all sides are equal. So here the opposite sides are equal. So if I am going to name this figure as A, B, C and D, we will not get all sides equal, but we will get opposite sides equal. That means AB will be equal to CD and AD will be equal to BC. So first property, we will get opposite sides of a rectangle are equal. Second property, in fact, is the same as what we got earlier. That means all angles of the rectangle are also 90 degrees. So we get angle A, B, C and D as 90 degrees. The third property, AC equal to BD, was in a square, and we can say for a rectangle also the diagonals are going to be of equal length. So we can say that AC is equal to BD. Fourth property, we saw here that diagonals are bisecting each other at 90 in case of a square. But in case of a rectangle, we find that the diagonals do not intersect each other at 90. So that property holds good in this case for a square only. So that property will not be used here. But if you look at the last one, that diagonals of the square bisect each other. So OA and OC were equal, OB and OD were equal. That property will be here also. That means in case of a rectangle also we observe that OA is equal to OC and OB is equal to OD. Hence we get 4 properties for a rectangle. Therefore both square and rectangle have some common properties. So the differentiation will lie in the sides being equal in case of a square. Here only opposite sides are equal. And secondly, the difference lies in the fact that here diagonals bisect each other at 90 degrees. However, in a rectangle, the diagonals do not bisect each other at 90 degrees. Let us identify the properties of a rhombus. A rhombus is a figure in which all sides are equal. All sides are equal which means that AB will be equal to BC, will be equal to CD, will be equal to DA. So all sides are equal. Second property, if you observe in a rhombus, if I join the diagonals AC and BD, they are going to intersect, let's say at a point O, and like a square, they are also going to intersect each other at 90 degrees. So here we can say second property of a rhombus, that diagonals intersect each other at 90 degrees. Then what about the angles ABCD? In square we saw that all the angles were equal to 90 degrees. However, in case of a rhombus, the angles are not 90, but the opposite angles will be equal. So angle A will be equal to angle C, they are opposite angles, and angle B will be equal to angle D. So only the opposite angles of a rhombus will be equal. Now if this is 60, this will be 60, and this is 120, this is 120, and so on and so forth. So the angle A and B, however, will be different. And a rhombus, if you observe, will have four sides as in any quadrilateral, and these, out of these four sides, the two sides AB and CD are parallel to each other, and AD and BC are parallel to each other. So this in fact is a parallelogram, and a rhombus with four sides equal and opposite sides equal will also be referred to as a parallelogram. Here if you look at the diagonals will not be equal to each other. So AC and DB will not be equal. However, in a square they were found to be equal. So you can be asked to differentiate between a square and rhombus, or you could be asked to find out the similarities between a square and rhombus based on its properties. How is it different from a parallelogram? A parallelogram is a figure in which opposite sides are equal. So all sides are not equal here, but in a rhombus we saw that all sides are equal. So a rhombus is a parallelogram, but a parallelogram is not a rhombus. So look at this parallelogram. We can say that AB is equal to CD and AD is equal to BC because they are opposite sides of this parallelogram. Secondly, opposite sides are parallel. So AB will be parallel to CD and AD will be parallel to BC. So these are the two main characteristics of a parallelogram, that opposite sides are equal and opposite sides are parallel. The diagonals will not be equal, they are of different lengths, but they bisect each other. So we can say that OA will be equal to OC and OB will be equal to OD. So diagonals of a parallelogram bisect each other. And next we can also conclude that the opposite angles, just like here in rhombus, the opposite angles are equal. So A will be equal to C and B will be equal to D. Opposite angles of a parallelogram are also equal. And for rhombus and parallelogram and square and rectangle, since the opposite sides are parallel and equal, the angles which are inside are called the interior angles, and there is a property that the co-interior angles will always give you a total of 180. In the case of square and rectangle it is 90-90, so it's obvious that it will be 180. But in case of rhombus and parallelogram, if you are given one angle, then the other angle can be found out by subtracting this from 180. So 180 minus 70, you are going to get 110. So we can have this property for all the four cases that we have discussed, that sum of the co-interior angles add up to 180 degrees, or we can say they are supplementary. Supplementary means they are adding up to 180 degrees. So if one angle of a parallelogram or a rhombus is given, we can easily find out all the angles. A trapezium is a figure in which one pair of opposite sides are parallel to each other. So here we find that AB and CD are parallel, but AD and BC are not parallel lines. So if one side is parallel to the other, then that figure is a trapezium. So we have AB parallel to CD. These two sides are not parallel, they may or may not be equal. So we cannot take for granted that these two sides are equal, but definitely we can say that they are not parallel. This may be equal or may not be equal. That has to be given to us in the question. Now, as observed, if these are parallel lines, then we can use the co-interior angle property here. If these are parallel lines, we can say that angle 1 plus 2 is 180 degrees, because the sum of co-interior angles add up to 180 degrees, and this process can be repeated here. So we get 3 plus 4 is 180 degrees, and therefore 1 plus 2 is 180, 3 plus 4 is 180, total will be 360. So the property of a trapezium, for repetition's sake, this will be a figure, a quadrilateral in which one pair of opposite side is parallel and sum of co-interior angles add up to 180. The total of all the angles 360, just like for any other quadrilateral. Next, the properties of a kite. Look at the figure of a kite. You find that AD and AB are equal, but the tail of the kite is longer as compared to the top portion. So here we have the two upper sides, adjacent sides, AD and AB equal to each other, and the adjacent sides here CD and BC equal to each other. The diagonals definitely are unequal, but the diagonals of a kite intersect each other at 90 degrees. So we can say that angle AOB is equal to angle BOC, is equal to angle COD, is equal to angle DOA, and all of them are 90 degrees. So diagonals intersect each other at 90. Now do they bisect each other? If you look at this diagonal, OD will be equal to OB. These two are equal. But if you look at this diagonal, this length is small and this length is bigger than this. So we will say that OD is equal to OB, but OA is not equal to OC. So a kite has the following properties. It has two adjacent sides, two pairs of adjacent sides equal, AD equal to AB, CD equal to CB. The diagonals are not equal to each other. One diagonal is small, the other is longer, but the diagonals intersect each other at right angles or 90 degrees, and here we find that the diagonal one side OD is equal to OB, but the other diagonal OA will be smaller than OC. So these are the properties of the 6 quadrilaterals that we have discussed, and in all these cases the common property will be that the sum of angles will be 360 degrees. Now based on these properties, you can be asked to find out some side, or you could be asked to find out some angle, and these have to be used, and these properties will be used to solve those